That's sad. If a lie detector detects a lie for 95% of liars, they detect a lie for others, so they get a false positive. So if you detect a lie, what is the probability that a lie is really being told or the person is really telling the truth? One of these examples is that you can go get a mammogram and it can detect cancer, but actually it doesn't mean you have cancer because of the false positives that could get, or the same thing with the COVID virus. So let's just go ahead and set this up then. Let's do a table first. So here we have a liar or you're not a liar. And the detector either detects a lie or it detects a falsehood. What I know is that 90% of Hoosiers lie, and 10% tell a lie, and it detects 95% of the liars. So what I would do is have 0.1 times 0.95, and that gives me 0.095. Now, if you're not a liar, it detects a lie for how many of those? 20% of the others. So if you aren't a liar and you tell the truth and you're 90% of the population, it's going to detect a lie 20% of the time. Or in other words, 0.18. So generally, if you add these up, you detect a lie 27.5% of the time. It doesn't detect a lie, well, 5% of the 1% is 0.005. And in the other case, those who tell the truth, 90% of them, 80% of the time, it does not detect a lie for 0.72. So now, let's kind of figure out how many people are liars. Add these two together, you get how much? 0.10, which is good because that's what we said. And what if I add 0.18 to times 0.72? I get 0.9. And if I go down, I get 0.725. And if I add these two together, I get 1, which is good because that should be the totality. So remember, given that you're a liar, it's going to detect you 95% of the time. So 0.95 times the probability you're a liar, that's going to be 0.095. The 0.1 is that given that you're a liar, 90% of the people lie, so 10% or 10% lie, and it doesn't detect you 5% of the time. So it messes up 5% of the time, so it gives 0.05. Yes, Jeff?
I mean, all that stuff in the table makes sense, but can you explain how it connects to the equation that we have on the last page?
Sure. If you think about it, the probability of L and detecting a lie is the probability of being a liar times the probability of detecting a lie given that you're a liar. So that you're a liar is 10%, and then it detects a lie for 95% of the lie would be this 95%. So each one of these is the probability of L times the probability of L prime given L. And the same thing all the way through.
Okay. So are we using the the Bayesian equation?
We're using Actually, I erased it. It's this equation right here. It's the conditional probability just moved across. We haven't yet used the Bayesian equation, but now we're ready to.
Okay, I thought we were gonna, so that's fine.
So we want to say, what's a lie? It detects a lie, so we're here. It detects a lie 27.5% of the time. So for this one, what we would get is 0.095 divided by 0.275, which is the probability of being a liar and detecting a liar over the probability of detecting a liar. So it detects a liar. So I take the probability of Al intersect D over the total probability. And what I get when I calculate that is 0.345. So if you're actually detecting being a liar, your chances of actually being a liar is only 34.5%. The person who's really telling the truth would be the second one, probability of telling the truth and you detected a liar would be 0.18 divided by 0.275, and that is equal to 0.66. So it actually does worse So actually, if it detects a lie, you're more likely to be a truth teller. All right, let's say it didn't detect a lie. The probability that you are a liar given that it didn't detect a lie would be 0.005 over 0.725, and the probability that you're a truth teller and it didn't detect a lie would be 0.72 divided by 0.725. So in this case, if it didn't detect a lie, you could squeak through 7 1,000ths. But if it didn't detect a lie, 99.3% of the time, you actually are a truth teller. This is quite remarkable. And that's why we have to be a little careful with when people test positive or negative for their COVID tests.
I thought you can only get, like in reality for the COVID test, you can only get false positives, not false negatives.
Well, that may be the case. Depends on which test you are, the saliva test, the one they stick down your nose back till they get to your heart, or the angina test where they take their blood. They all have different.
I didn't know that you could go there.
Let's try this next one, where you're classified as a flood hazard based on geographical areas. And by the way, more areas are now being classified as flood areas. So you have a flood hazard of low, medium, and high. And then 75% of your claims are low, 20% are medium, and 5% are high. So the question is, what if you have a policy that works? So we could think of it as a tree diagram. 75% are low policies, 20% are medium, and 5% are high. So the chance that your high one has an accident or has a flood would be 0.75 times I'm sorry, your low would be 0.75 times 0.002. And the chance that you didn't have a claim would be 0.75 times 0.998. In the middle here, you have 20%, and so given that you're 20%, the chances that you have a medium one is 0.05 or 0.2 times 0.95. So this is 0.01, 10%, move the decimal place over 1. And we'll have to pick that up on Friday. So there are two ways to do this. One is with a table, and one is with a tree. And I got tricked up a little bit. Okay, so on your way out, if you could turn in your group and test survey into this box. I'd appreciate it. Remember, you have homework due tomorrow at 2 o'clock, either in person or online. And have a good Wednesday. You should be around most of the afternoon, well, except for maybe 3 o'clock. If you have questions about the homework or about the lab.
Dr. Chase, do you know what the lab is due?
Friday?
Friday.
Yeah.
You also like to